This conference will now be recorded.
Hello friends, welcome to another session on data science. Just give me a second. Okay. All right. So today what we will do is we'll discuss about different modules involved in the data science. So entire course is divided into multiple modules. So I'll go through the modules. We'll try to see like what are the important areas we should cover and what we will be covering. The topics for those areas. We will also get an understanding of how these sections are divided and what will be covered in those sections. That's the topic for today. So in fact, if you have any general questions, you could use the chat window and ask the questions. If you have a bigger question, you can unmute and then ask. All right, so let me start. So this entire course, it is for 3 months. We will be doing a data science course starting from tomorrow. We will do it for roughly around 3 months. That's the time frame we are looking for, and it would be a daily class and a 1 hour duration, and we will be doing from Monday till Friday, and we'll be continuing for 3 months. And I have designed the course in such a way that we will have a lot of practical uses of how the real world data scientists work in the real world. So we need to understand multiple basics. Apart from that, we need to do a lot of hands-on. So the thought process was to design it in such a way that we will do a lot of projects. And while we are doing all the projects, we will learn about how the data science is done in the real world. So that is the prime focus. So our intent is not just to learn a specific algorithm, get a result, and show the result or a percentage of the result, accuracy, and so on. So those are we would see that there are a lot of things which are happening, and many people are doing that. But my intent was to create in a such a way that we will do a lot of projects, and when we are doing a lot of projects, we will get a lot of expertise in the things pertaining to the data science. You will not learn swimming if you're just sitting on a shore and then just watching the water, right? You need to jump into the water, do the practice, then only you will be able to learn the swimming. Same is the case with any other skill as well. So we would need to jump into the code, jump into the practice, and do the practice our hands-on. Only then you will be able to learn it. Okay. So my name is Sitaram, and I have around 15 years of experience, and in the data science area, around 8 years of experience. I'm working in the data area. I used to work as a big data architect in the last decade, I would say. And for the past 3 years, I'm working as a data scientist for an MNC. I also currently work for the same MNC, but I also do teaching. I have a great passion in training and teaching and other things. So for the past 6-7 years, I'm also doing trainings. I did trainings on big data, Hadoop, data science, Python, and other ones. Currently, I conduct a lot of classes with data science. So I have collaborations with Career IT for taking data science classes, and that's the reason I'm here. Coming from my education background, I have a MTech from BITS Pilani in data science, and I'm currently pursuing my PhD in computer vision and deep learning from IIIT Hyderabad. So that is about me, and definitely you'll learn about me more while you go through my classes. You will also see my way of teaching and methodology I followed and so on. So I would recommend to attend a couple of few classes so to get an understanding of how things work, so that you will get a more understanding. But today we'll break down the entire session into multiple modules. I will talk about what are the different modules we'll be covering throughout the course. So first and foremost, we will talk about data science, the foundations of data science. We will talk about general about data science, like what is data science, what is AI and machine learning. We did a few demo sessions. You might have already attended these demo sessions. So if you have missed some of them, we would share all the videos. All the videos will be recorded. This is a live session and the videos will be recorded for the session. And in fact, if you have missed any of the sessions, we would be sharing all the videos with you so that you can go through the videos and then get an understanding. Math for data science is a very, very important topic. Mainly, many people will miss this topic. People say that anyway, we are using tools. Why do we need to know about mathematical concepts? From an application standpoint, nobody going to derive equations and solve the algorithms. But definitely from an understanding standpoint, we need to know like how these algorithms are applied, which if you tune what parameter the algorithm will perform better, how we can do optimizations and all that stuff. So for that, we need to have a basic understanding of mathematics. Now, because we have learned these mathematical concepts many years back, we might have missed these, we might have forgotten these concepts, say related to the linear algebra, matrices, eigenvalues, eigenvectors, how the vector transformations happen, things about probability and calculus. So some of these topics might be daunting for somebody, maybe like a guy like me who is already 15 years of experience, have done college almost 20 years back, who might have forgotten such kind of topics, and it should be like a refresher for somebody who wanted to dive into data science. So without mathematics, if you are going to any of the data science topics, I would say that you are fooling yourself. We need to have at least a basic understanding of why we apply differentiation, what is the reason for probability, how we do calculus and other related things, how we do linear algebraic functions, matrix operations, and so on. All those things are very, very essential. As mathematics, we also have another topic which is very essential, which is statistics. Now, once we have a strong foundation in mathematical concepts, we will then delve into something called as statistics. Specifically, we'll talk two important topics: descriptive statistics and inferential statistics. Now, statistics is a field in which we are trying to make sense of data, trying to get patterns of the data and do a lot of things. Now, descriptive statistics talks about the past information. Now, we already have the data available with us. Now, we are trying to describe the data. Now, imagine last 1 year, we have collected car sales for a famous car manufacturer, say in India, like Maruti company. So we have collected all the car sales. Now, from the car sales data, we are trying to identify, uh, where the car sales were higher, where the car sales were lower, what is the projection of the car sales in the coming few months, and so on. So with that data, we call that as descriptive analytics. We already have the data. We are trying to describe what has already happened. Now, when we are doing the descriptive statistics, we will learn about something called as different measures, the measures of central tendency like mean, medians, and mode, measures of dispersion like variance, standard deviation, range, quartiles, interquartile ranges, measures of shape like skewness and kurtosis, and different types of probability distribution functions. How are the correlations? How are the regressions? See, all these things we will be working on the current data. Already the data we have, we will be working on the data, and then we will be using that for our predictions. Now that is on the descriptive statistics front. The another important area is the inferential statistics, where we are trying to infer from our experiments. So this is more used in the areas where we can't work on the entire data or entire population. So there is a concept called as population and a sample. Imagine a drug company wanted to release a vaccine for COVID patients. There are thousands of patients. Now they can't test the drug on those 1,000 patients. what they will do is they will take a sample of that. They'll take, say, 100 patients and then test the drug on that 100 patients. Now, if the results are positive working on those 100 patients, then they will extrapolate the results to the actual population. Now, this is called as inference. Inferential statistics talk about all these areas where we try to take the statistical sampling, we try to do inference, we try to create a hypothesis, ensure the hypothesis testing, understand about null and alternate hypothesis, identify different types of errors, what are the type 1, type 2 errors, different types of tests like one-side test, two-side test, type of inference test like chi-square, t-test, analysis of variance, and t-value, p-value, confidence intervals. And likewise, there are different types of errors which will be captured and analyzed, and all those things will be understood. And that is what we call as inferential statistics. Now, once we do the inferential statistics, we will use Python for data science. Now, after the statistics, we will get into the Python part. Now, Python is the go-to language for data science right now. There are other languages like R and Java and other ones, but they have slowly faded away. R used to be a very good statistical language in 2010 and 2012 and so on. But as and when the Python has picked up, and a lot of companies, especially the big ones, have adopted Python and created a lot of frameworks related to that. So there are frameworks like TensorFlow, PyTorch, and other ones which were created by Google and Facebook, which is using Python extensively. So when we are using this Python as a language, and when we have the support from the community, there are a lot of Python developers, and Python community is growing and so on. So you have that language as a prime language. One other great advantage of Python is that it is a general purpose language. It could be used for a lot of other things, not just data science. We could create Python websites. We can use it for creating APIs. We can use it for doing database background tasks. We can use it for automation and a lot of things. Now, when we are seeing all these things can be done with Python, we could, we can build better systems by using Python. So in this course, we will be talking about Python for data science. Now, here we might not be talking about basics of Python, like what is a function or how to define a variable and all those things. I will be assuming that people already know some basics of Python and so on. If not, I would recommend to get in touch with the Career ID team so that they can let you know like what are the courses they are offering for Python. Many of my students take parallel batches. So because Python, just from a language standpoint, they could quickly learn that and then get into the Python for data science, and we would do the entire data science course. So Python for data science, what I will be covering is all the key components which are involved in creating data science programs. We need to create these data science programs and modules and all that stuff. So for that, we need to act with some of these libraries, primarily the NumPy, Pandas, Matplotlib, Jupyter Notebook, and so on. So we need to, is there a question? I request everyone to go on mute if you're not speaking. Thank you very much. So what we are looking here is we will be looking at different types of modules. So NumPy, Pandas, Matplotlib, Jupyter Notebook, these are different types of modules which will be used for creating the Python programs, for the data science programs. Especially we will be talking about NumPy, which is a numerical Python library. We will be comparing NumPy lists, indexes, slicing, copies and views, creating numerical operations, matrix operations, aggregation functions, your shape manipulations, doing statistical operations. See, all these things will be used in NumPy, and NumPy is a numerical library which is used for doing all the number operations. Once we understand about NumPy, we will get into Pandas. Pandas is basically an all-purpose tool. So it's more like a database. It's more like a CSV file where we can do a lot of transformations using the data. We will be having something like series and data frames. We could do selection slicing, we could do joins, we can do merging, we can do group by operations, we could do visualizations using pandas, and so on. A lot of things can be done. So that's the reason this is called as an all-purpose tool, an all-purpose tool which is combined for doing a lot of different transactions. Coming to the data visualization, we will use data visualizations using matplotlib. Matplotlib is a library where you could use it for doing some plotting. We could look at anatomy of a matplotlib figure. We could do plotting the lines and the labels, colors, and so on. You can apply scatter plots. You can apply box plots and scatter and different kinds of plots will be done using matplotlib. Now, Matplotlib and Seaborn are the two important libraries which are used for data visualization. Now, I want to visualize the data. I want to understand what the data is saying. So such kind of understanding is required at the start of the data analysis and at the end of the data analysis. At the start of the data analysis, I want to understand how the data is represented, what are the patterns of the data, how they are related. All those things will be bigger questions for understanding the data. That's during the start of the analysis. At the end of the data analysis, we will try to measure how correct is our analysis. We are trying to see whether our analysis is good, whether we are able to properly represent the data or not. So all those things are very, very important. So we will try to apply our techniques, and we will try to analyze our data after our analysis is complete. So Matplotlib is one of the basic tool, but there is another library called as Seaborn, which is even more powerful. Now with Seaborn, we could do even more quality visualizations. We can apply varied kinds of plots, violin plots, box plots, cat plots, facet grids, swarm plots, pair plots, your LM plots. Likewise, there are variety of plots which are available. And whenever we are doing data analysis, and when we want to represent our data as a story, we want to create a story of our data analysis, then Seaborn is the go-to library that will be used for creating all these graphs and charts and so on. So once we have done some basic analysis, once we have used all the tools and created an understanding of the data, we will get into something called as exploratory data analysis. Now, exploratory data analysis is the most important area which will be used by a regular data scientist. Now, this is the area where we are trying to understand the data, identify the patterns of the data, do some transformations on the data. So we would require to acquire data, we would need to prepare the data, we would create a model out of it, and so on. Now, for that, we need to understand like how the data would be acquired. What are the different data inputting options? How do we read the data from the CSV files? How do we read the data from the database? How do we read it from a JSON file, and so on? And how do we do the data preparation? The data preparation will be requiring a lot of pre-processing techniques. We would apply like transformation, standardization, normalization, encoding, one-hot encoding, label encoding, inputting, missing value imputation. We will do train test splitting, etc. So there are plenty of techniques which are used for transforming your data. Now, because the data is in a very raw format, if you are trying to give that raw format data to your machine learning model, your model will be behaving very, very badly. Now, what you need is you want to transform your raw data, and then you want to create it in a meaningful format. Once you create the data in a much more meaningful format, you can use that meaningful data to perform better results, right? So we will be looking at these options of different types of transformations. We will learn about what all different transformations can be done on data, and once we have done those transformations, we can predict that into send that into a machine learning model for doing future predictions. So once we do all this transformation, now the data is ready. Now the data is ready to be fed to any of the model. So what we do is we will learn about the next section called as machine learning. Now this is the area where we will be understanding about the introduction to machine learning. We will look at different applications of machine learning. We will understand what is the supervised machine learning and unsupervised machine learning. And within the supervised machine learning, we will look at classification and regression use cases. We will learn about different types of unsupervised machine learning, reinforcement learning. We will learn about different advances in the machine learning. How do we do model representation? How do we do model evaluation? what are the steps to be followed for doing hyperparameter tuning of your machine learning models, and how do you evaluate these models in the real world in production, and deploy those strategies in the production. See, all those things we'll be learning in this section, where we will be covering about the basics of machine learning. Once we understand like how to deal with all these machine learning models, we will go deeper into each and every model. So we'll go into supervised machine learning classification use cases. Now, classification is the use case in which we are trying to predict one or the other classes. For example, I am predicting whether to give a loan to a person or not based on the risk appetite. Now, that is a classification problem. If I'm looking at a document and I'm trying to predict whether this email or a document is a spam email or not, that is a classification problem. If I'm looking at an X-ray scan and trying to predict whether the bone is broken or not, or looking at a diabetic retinopathy retinal image and trying to predict whether the person is having diabetes or not. So these are all the examples of the classification problems where we are predicting something belonging to a specific class. Now, within the classification, there are plenty of models. There are k-nearest neighbors, decision trees, naive-based, stochastic gradient descent, support vector machine, random forest, gradient boosting, XGBoost, logistic regression, and so on. Now, these are few models, and don't get overwhelmed with all these names. These are some of the models we will be learning throughout the course, and every model has their own advantages, disadvantages. So we will be comparing what are the advantages and the disadvantages of the model, which model has to be used when, and for what type of data, which type of model is best suited, and so on. So we will learn all these things. We also have something called as ensemble methods, which are like combinations of models. Now I can combine XGBoost, support vector machine, and a random forest, and I can make a jumbo model, and the jumbo model will be performing even better than individual models each. So when you're combining such kind of models, that is called as ensembles. We will see like how to combine models, what are the different techniques of combining, like bagging and boosting, how do we apply voting classifiers, how do you find out the best choosing classifier, how do you combine all the models and make a what I call as a jumbo classifier, how do you make all those jumbo classifiers, and so on. We would also learn about model tuning techniques. Different types of techniques are there, like train test splitting, cross-validation, K4 cross-validation, variance bias trade-offs, how to apply L1 and L2 norms, how do you identify overfitting, underfitting, and different curves which could be plotted for identifying all the parameters, and how do you do hyperparameter tuning, and by grid search CV and other different techniques where you can automatically tune the hyperparameters to get better results. These are some of the techniques. Apart from that, we will also do accuracy, confusion metric, precision, and recall, which are used for identifying performance measures of the metrics, and those are used for doing better predictions. Now, getting into the machine learning space, we will next go into machine learning regression. Now, regression is a case in which you are predicting numerical outputs. Now, numerical outputs is basically where you are predicting. Suppose I take the same loan example. As I'm predicting a loan example, if I'm predicting the loan amount, so predicting whether the candidate has to be given a loan or not falls under classification, but how much loan a person should get falls under something called as regression. In regression, we are predicting the number term. So 2,50,000 loan can be approved. Number of cars number of cars produced by the company, right? What will be the house price of the apartment, right? Similarly, there are different kinds of use cases in which we are trying to predict the number term, which is like the profit of the company, revenue of the model, and different other things which falls under a number term, and a number term is called as a regression. We are trying to predict continuous numbers which will fall under regression use case. Within the regression also, we have a lot of different use cases like linear regression, variants of regression like lasso and ridge regression, multilinear regression. How do you do polynomial regression, random forest regression, support vector regression, and different other types of models. We would also do a lot of test metrics. For example, we will test mean absolute error, mean square error, root mean square error. Likewise, different types of error metrics are there, which will help us to create better models using these regressions. Once we do the classification and the regression use cases, we will get into something called as unsupervised machine learning. Now, unsupervised machine learning do not have any class or an output where we can map to, but we will be trying to create some clusters and groups. So we will create k-means clustering, hierarchical clustering, dbScan, and different kinds of clustering tools. We have different types of association rule mining techniques. We will do something called as market basket analysis, dimensionality reduction using principal component analysis, and so on. There are a lot of techniques which will be used in the space, and the different kinds of tools will be used in this particular space. Coming to the natural language processing, natural language processing is another important area which we'll be covering after the unsupervised machine learning. Now, this is an area where we are using this natural language to do some predictions. Now, imagine I'm looking at a comment, I'm trying to identify the sentiment of that comment. That is a natural language processing. I'm looking at a document and trying to classify the document into an entertainment category or political category, sports category, or whatever category. Automatically, a machine is doing it. So that falls under natural language processing. So we'll try to understand the natural language. We'll try to do some analysis on the natural language and then try to find out the results. That all falls under NLP. We will do text analytics. We will identify some sub areas of NLP like stemming, lemmatization, stop word removal, parts of speech tagging, name entity recognition, create term document metrics, create count factorizer, term frequency, and TF-IDF. Likewise, there are different other techniques which will be used for extracting information from the textual data. Now, that is a difficult task. So we will learn all the important techniques which will be used for extraction of your data. Once we complete NLP, we'll get into some advanced analytical topics. We will look at time series data, ARIMA models, content-based recommender systems, collaborative filtering, and so on and so forth, which are some of the advanced models we will be learning. We'd also be concentrating on reinforcement learning. Reinforcement learning is another area where we are providing a feedback mechanism to the model. So the basic concepts of the reinforcement learning will be understood. We'll be talking about reward and penalty based models. We will understand how the feedback loop can be created and how to apply deep learning based models for the reinforcement learning. Once this is completed, we'll get into AI, artificial intelligence, where we'll understand about artificial neural networks. We'll create how the neural networks will be used, what are the basic terminologies, what is a perceptron model, what is a feed-forward network, what is a backpropagation, how do you apply gradient descent, and how do you use mathematical concepts for the gradient descent models, how do you do linear algebra, eigenvectors, eigenprojections, vector quantization, and different other tools like TensorFlow and Keras for applying the neural networks. We will get into the application of neural networks, which is called as deep learning, and deep learning is used for doing a lot of deep learning based models. We will get into how do you create multilinear perceptrons using deep learning, how do you compare the hidden Markov models and Bayesian models, how do you perform deep learning optimization techniques, how do you create prediction models of a gaming company, how do you build an image similarity classifier, and so on. All those important applications we will be discussing in this particular area. We will be getting into deeper concepts of deep learning like convolutional neural networks and recurrent neural networks. In convolutional neural networks, they are used for images and video classifications. We will understand the architecture, different types of convolutional layers, how do you apply different filters in kernels, how do you build image classifiers using CNN. So those are all things we'll be learning in this topic. Next area we will be discussing about is recurrent neural networks, where we'll try to create chatbots using recurrent neural networks. We'll try to identify the training sequence classifiers. How do you predict time series classifications using RNNs? So those are all the different topics. Once we complete deep learning, we will cover two other important topics, which are cloud computing for data science and DevOps for data science. And I actually give a lot of importance for cloud computing and DevOps. The reason is because data science doesn't work in silos. No, we are not here to just do some experiment and create a model. We need to create applications which are working live. We are not just here for creating a POC, show it to your boss and then make them happy. We want to create real world applications which are working in the world. And without cloud computing and DevOps in this current world, these applications are not going to be deployed or working in the real world. In few years later, a few years before, people used to create standalone applications. On-premise servers will be used, but nowadays everybody is moving towards cloud. So it is very, very essential to have this cloud knowledge and DevOps knowledge so that we can sustain for a longer period of time. And I would say these are the deadly combination. So having a depth knowledge in data science and breadth in your cloud computing and DevOps is a deadly combination, and somebody who has this understanding will be sustaining for a longer period of time. And that's the reason, focusing on those things, I have introduced the concepts of cloud computing and DevOps. I have great experience in AWS, so I'm talking about AWS from a cloud perspective, but this will be applicable similarly for Azure or GCP. Both will be in the similar lines. We will see examples of how do we deploy models in cloud. We will understanding the cloud computing concepts. We will look at some of the preliminary services which will be used for data science and so on, like S3, EC2, RDS. How do you use container services? How do you deploy big data processing on EMRs? How do you use machine learning model deployment using Amazon SageMaker, and deep learning using AWS Cloud, natural language processing using AWS Lex, and so on. So these are all the important topics which we'll be covering on cloud computing. The focus is like, how do you create an end-to-end model deployment on cloud so that your project can be going live. Another important area which I'm focusing is on the DevOps side. Now, DevOps is a very generic topic right now. Everybody needs to know DevOps. And then if you are not knowing DevOps, then you might have some problems in the coming future, because everything will be automated using these DevOps pipelines. Now, DevOps is nothing very, very big. We need to understand, like, if I want to deploy my data science model, what are the different pipelines I need to use? How do we deploy them in the real world? How do you create containers? How do you deploy these models using these Docker services? And how do you scale these models using Kubernetes and other kind of services and so on? So here we will be covering our Git, your Jenkins, Docker, Kubernetes. So these are all topics which will be used, which will be helping us to make this models in a real world, right? So what all things we covered here is to understand the entire cycle of your data science. We need to start understanding the basics of data science by understanding mathematics and statistics. We need to have a core understanding of how this data will be processed by using exploratory data analysis and data pre-processing. We need to understand different algorithms and algorithmic process by understanding different machine learning models, deep learning models, natural language processing applications, and so on. And in the last, we need to have a strong foundation on cloud computing and DevOps so that we can have the entire package. So this entire journey will be going through 20+ projects. I have designed the entire course in such a way that we will be doing all these things using projects. So many projects will be there. For every model, we will be having an associated project, a small project, so that we will be taking a real world data set. We will be creating a small mini project using that data set. We will see like how to do a data pre-processing, how to apply a model, how to tune the model, how to get the results, how can we do the predictions using the model. So likewise, we will be creating 20+ projects. So I'll be just walking you through the projects so that you get an idea of what will be covered. So I've given a list of projects. So we'll be building an XML to CSV converter using Python. This will help you to understand the basics of Python. It will test your knowledge on Python. How do you create this application. Likewise, we'll be getting into a photo editor application. We will create a photo editor from scratch using Flask and NumPy. Now, this will help you to create end-to-end application. Like we will be creating a web application, which will be a photo editor where we'll be uploading photos and changing your contrast, expansion, your compression, and applying some color, tint, and other things using NumPy, where we will understand about matrices, metrics related operation, performing image operations using NumPy. Lot of things will be learned here. We will be doing exploratory data analysis for retail shop sale data. Now this is helping us to understand what kind of exploration can be done on retail data. This will give us all the basic steps of data pre-processing, how we apply scaling, how we apply encoding, how we do missing value imputation. All those things will be learned here. Then slowly we will be penetrating into different machine learning models. We will do a fruit prediction using k-nearest neighbors by applying k-nearest neighbor algorithm. We will get into predicting malignancy using mammographic masses, using decision tree classifiers. So these are some of the basic models. Slowly we will be getting into some advanced models like random forest. We will predict whether a candidate will be shortlisted in H-1B visa using random forest algorithm. We will predict breast cancer using support vector machines. We will do HR analytics for attrition prediction using logistic regression. We will do churn analytics using in telecommunication using support vector machine, k-nearest neighbors, and other ensemble methods. We will be doing house pricing predictions using linear regression models and multilinear regression models. We will do social network ad prediction using hierarchical clustering, retail customer segmentation by spending patterns using k-means clustering, market basket analysis using a priori algorithm. We will do spam prediction using natural language processing and machine learning. We will do sentiment analysis on restaurant reviews using natural language processing, supervised machine learning, and so on. We will do image classification using deep learning and convolutional neural networks, and content-based recommender systems using deep learning, where we will be using CNN models and transfer learnings in deep learning. We will create chatbots for end-to-end recurrent neural networks for creating deep learning models. So this will help us to create and real-world chatbots where we can interact with the chatbots and do some operations. We will create a stock market prediction model for predicting stock market and for doing time series forecasts using stock markets, and exploratory data analysis on crime screen data by applying linear regression, XGBoost, and NumPy and other models. So what we have seen here is this is the entire jam-packed session. At least 20 projects will be there. Apart from these, we will be following few more projects which will be requested from course participants. I would encourage people to come up with their own application areas. So you might be working in retail, you might be working in healthcare or banking or any other industry. So I want throughout the course, I would be encouraging people to come up with their use cases so that we can get some practical insights and we can solve some practical problems. So apart from these 20 projects, we will be doing a lot more projects, and focus would be doing project-oriented learning so that we get a technical expertise after we complete the course. In the end of the course, we would also be giving some insights on how to attend interviews. I will be giving a lot of frequently asked questions, interview questions, so that you can practice those questions and then can go and crack an interview. A lot of previous participants have done these entire exercises as planned, and then they were also able to get better jobs. Like many people shifted within their organization, they have applied for external jobs and got a lot of opportunities and so on. But the focus should be on how you have done and what is your current expertise, how we can mold your expertise into getting into a data science. So that should be your focus. So as I said, the duration of the course would be 3 months, around 3 months. So now when we are starting in April, May, June, so kindly by somewhere around June, we will be completing the course. And the schedule will be every day. It will be a daily 1-hour session. We yet to decide the timing, but technically it will be around 6 or 6:30, 6 a.m. to 7 a.m. or around 6:30 to 7:30 a.m. Indian Standard Time. If you are in other time zones, maybe in US time zones or other time zones, you have to map the timing accordingly. It will be 6 a.m. IST would be somewhere around 8:30 p.m. EST. That will be the timing, but you need to manage that and see that schedule accordingly. It will be a weekday sessions, Monday till Friday, 1 hour duration, and for the coming 3 months. Any questions you have? I hope the session space was okay. You are able to follow me throughout the session, and depending upon your requirements, I will be changing the pace, maybe going a little slow or a little fast, depending upon the requirements. Any questions? So there will be the course would be starting from tomorrow. So I would recommend everybody to attend the course. You can go through some of the sessions, and if you feel comfortable, you can go for enrolling for the course. We will have our course coordinators who will be talking to you. They'll be interacting with you regarding your feedbacks, and if you have any questions, you can ask them, and they will be happy to help you. So a basic targeted people will be somebody who see this. There are different types of jobs for data science people. There are entry-level professionals who can get into data analytics, who can get into ML roles. Front-end developers who are already available, who are already working in the front-end space, they can get penetrated into ML developers, app developers who will be interacting with ML engineers who can create APIs, deploy the models as APIs. So there are specific roles which are suited for every experience. Somebody who is a front-end developer can get into something called as ML engineer role. Somebody who is a back-end developer can get into a junior data scientist role. Somebody who is already a ETL developer can get into a data engineering role. So there are different types of roles suited for different people. And depending upon your previous expertise, I would encourage them to get penetration into those areas, so that once they get an entry, they can slowly get into data science, and then they can do a lot of more work related to the data science. But depending upon your previous experience, you need to act accordingly and use that expertise to get penetration into the data science area. I would expect that people who are attending this session has some basic knowledge of programming. Doesn't need to know Python as such, but at least need to have a basic understanding of some programming. So that expectation is there. So because I'm not going to talk about what is a variable, what is a function, how do you create a class. That will elongate this entire program by few more months, which is not at all necessary. And learning that is not a very difficult task. If somebody who is already working in IT, they will already know like how these things work, and they will quickly can grasp all these topics. And anyway, we are talking about Python for data science, where I will talk about all the basics which are required for creating a data science model, right? So it should not be a difficult task. All right. Any other questions?
One question. Yeah, one question. But what is the duration of this course?
3 months.
I mean, it's a 3 months. Okay. Is it like a daily session, or is it like a weekly? I mean, thing.
It is a daily session.
Okay.
Every day 1 hour.
Oh, okay. Is it the same time, or is it like a fixed times, or is it going to change day to day?
Mostly fixed, because I have multiple classes, so it will be mostly fixed daily, 1 hour from 6 a.m. to 7 a.m. IST, or that correspond to your time zone. Whatever that time comes, you just look for that.
Okay, basically, it's 6 a.m. to 7 a.m. you're saying, right?
Right.
Yeah, so for 1 hour class, after 1 hour, how much effort should one put? I mean, I'm working professional, so I'm seeing where it fits in my calendar or like how much effort is needed from one side.
See,
So
I
for
would,
1 hour, yeah.
yeah. So this is a general question which is asked. So I would put a 10-hour effort per week. Okay. How do you divide that? We can. It's a questionable thing. But 5 hours will be our session, and 5 hours additionally, 4 to 5 hours you have to give throughout the week. You could divide that over the evenings or maybe on the weekend. So that will be a ideal suiting. So if you are able to allocate 10 hours, 5 hours for our class and 5 hours additional for your learning, then it will be the best use of your time. It doesn't need more than that, but if you are able to allocate 5 more additional hours apart from my learning, it should be good enough.
So is it the same for front-end developers and also like I don't have any ETL or much. I'm very good at visualizations and like front-end parts, but I'm not much into ETL or any backend. But these days, whenever I attend meetings or anything, I always see random forest or like whatever fishbone something, and then I got like okay, people are doing amazing things, and somehow I
Hmm.
got attracted. But I want to see how realistic it is to
So
me.
this is the general times I'm telling. Somebody who is already having an expertise and all, they will not require 5 hours also. They will be able to do the grasp concepts using 1 2 hour practice. But this is a general timing. Somebody who is having no knowledge at all might require little 1 2 more hours more of practice. But the general timing I'm giving. So general effort which is required. 5 hours is a general effort.
Okay, thank you. That helps.
And because we will be meeting every day, if you have any questions, so I would recommend people to go through the concepts, go through the topics, come back, because we will have a pretty much stringent schedule. So we will know like what we are talking today, what we are going to talk tomorrow and day after. So I'll also encourage people to come back with some preparation. So if they are having any questions, we can ask them in the class. So I will spend around 5 to 10 minutes in the class for any questions during the class, and so we can talk about that, right? So that is the way we go, because a daily interaction will be there, and it is like a live session. It's not like a pre-recorded session where you have to listen. So I'll be speaking, and if you have any questions, I'll be answering those questions live.
Okay, thank you.
Any other questions? Okay, which role suits for banking functional profile? So there are roles like data analyst role, business analyst role, junior data scientist. These are some of the roles which are very suitable for a banking professional. And if you are from a non-technical background, I would say like a data analyst role, which would be using some amount of modeling, some amount of data processing, some amount of data visualization. So combinations of those things will be used for that role. So that is the role to suit for. But definitely this course would give much more than that. You would be getting an entire 360-degree view of what things are happening. And depending upon your capabilities, you can slowly pitching into one profile and then slowly graduating into other different roles, right? So any role which is on a basic level is going to extinct in any coming few years. So a lot of things are getting automated. So what our focus should be is not to settle in a basic role. We need to kind of go into a role which would require more human intensive task, so that it will be sustaining for many years to come. You are seeing that a lot of tasks are getting automated in many areas. So it is in the infrastructure development, or maybe in the database management, or maybe testing. So you're seeing that a lot of things are getting automated. So being in a role which would demand a lot of human involvement, that is going to sustain for a longer time, right? So as a fresher, can I start the career in data science? See, I would recommend you to have a programming background if you're not from a technical background. See, I would not go and sell this course to anyone. This is not um, specifically for a fresher. Now, if I say like, okay, you're a fresher, you can learn anything and do it. If you already have a background of programming, I would recommend. But if you do not have a background on a programming and you are very fresher and venturing into data science, it will be a little challenging for you. I'm not discouraging people. I'm giving a realistic picture that it will be a little challenging for you. What I would recommend is you do a very good course on Python. Python is very, very important, and it can be used for a lot of applications. It could be used for web development, it could be used for data science. And once you have a Python basics foundations, then you can think about it. Give a month's time and think about it, and then you can get into data science. And that is my genuine suggestion. I can say like, oh yeah, it can be used for everybody, anybody can join, and you will get jobs after 3 months and all, but that will be fooling yourself. Okay, keep your foundation strong, learn some very strong foundation basics, basics on language, basics on database. Those are all very important, and once you have the strong foundation, then you can venture into other fields.
So I have one quick question.
Hmm.
In case if we have to go back and learn Python and come back, so when will be the next batch? I mean, if we think we are not ready for this batch, then will it be like every quarterly you'll be starting another batch?
See, what I'm saying is, if you are already working, right? There are multiple things, right? Somebody who has never done anything and you don't know anything about ABCD of programming, that's a different case. But if you're already working and you already know like how things work, and you have done some programming in other language or something related to IT before, then you will be able to
I
grab.
do understand SQL, but Python is new again.
Yeah, so as a language perspective, it might be different, but what I'm saying is we will be covering Python for data science, right? So there we will be covering all the Python concept related to data science. So if you can spend few hours and quickly get the basics, like what is a variable, what is this thing and all, then you will understand the language part of it. Okay, that's one suggestion. Second suggestion is, no, like I really wanted to have a very strong foundation on Python. Then you can get into one of the batches. Career IT will have some batches in Python. So they will teach you the basics of Python, and then we can get into the data science course. We have batches running throughout continuously, so you could learn that. And many of my students, previous students, they have done parallelly, because Python is just a small course, right? It will quickly complete in a month or so. So people can do parallel courses also, depending upon their timing. I have seen that many people have done this parallelly, and by the time, because this first entire module will take around 1 month, so in 1 month we will be covering the Python for data science. Parallelly they will be doing Python basics also, so that they can manage. Provided you can manage, I can do that, or else I would recommend to do course separately.
Okay, thank you.
All right. So come back tomorrow. I am hoping that you guys join. Doesn't matter would you like to join or not, but certainly join the class and see if that suits you. Then we can take decisions. You can talk to our course coordinators. They will be happy to help you with any of the questions, general questions. If you have any technical questions, certainly you can shoot it to me. But any general questions regarding course, when is the course, how parallel the batches will be, and what would be the fee structure, or whatever that is, you could talk to them, and they will be happy to help you. All right, so tomorrow same time we can have the class and take it forward. Till then, take care, have a nice weekend. Bye bye.
Thank you.